So I can share the screen, right?
Yes, sir.
All right.
Yes, sir. Your screen is visible.
Okay. So, let me show slideshow. All right. Good morning, everyone. Thanks, Rao, for that introduction. Today, I'm going to talk about end use of closed landfills. And before I get started, I want to thank Dr. Rao and Dr. Ramya for organizing this excellent short course. And I want to congratulate you for taking this course, because I don't think you will have a better opportunity than this to learn about landfills and waste containment systems, which is a very, very important topic in Indian current scenario. So be proud of taking this course, and hopefully you will make use of what you learned in this course for your research or for your career, and whatever way it could be useful. And as Dr. Rao mentioned, I would like to interact with you. I know I gave 2 presentations earlier, but unfortunately I didn't have much time at the end to. So I'll appreciate everyone muting the muting. So Dr. Rao, you should have a control on muting people.
Sir, please carry on. Sir, please unmute yourself and continue.
Okay. Is it clear now?
Yes,
yeah.
sir.
Yeah. So last 2 presentations, probably I didn't have enough time to answer your questions. Hopefully today, I have extra time so that I can answer any questions that you have on this presentation or, on this short course in general. So type your questions in the chat box, or you can talk to me directly at the end of the presentation. Okay. So I am from, Chicago. So Chicago is a beautiful place to visit. Let me just see. Okay. So you might have seen the map of US, and you know where Chicago is. And Chicago is a beautiful place. So if you get a chance to visit US for any reason, so you're more than welcome to visit me. These are all like touristic places, and the city itself is really good in terms of infrastructure and environment. And the last 2 pictures that you see here at the bottom, they are my campus. So before I get into the lecture, let me introduce what I do for research. You might have seen my name, at several, places related to different research. So I just wanted to give you an overview of what kind of research that I do. So I work on environmental remediation of soils, sediments, groundwater, and stormwater. This is more like related to environmental, but it deals with the geomaterials, soils, sediments, groundwater, and stormwater, anything that touches the ground. So I am involved in developing the new technologies, especially in situ remediation technologies, and addressing mixed and emerging contaminants, and mostly looking at heterogeneous and low permeability subsurface environments. So I work on different types of technologies, integrating them or optimizing them. So, starting with physical, chemical, biological, these technologies that I mentioned here. So I worked on all those technologies. So the reason why I work different technologies is you have to match the subsurface conditions with the technology. So there is no one technology that can take care of the expected situations in real world. And recently I've been working on green, sustainable, and resilient remediation. So that's one of my major research areas. And the second research area is related to this short course. I work on waste management and landfill engineering. So waste management, deals with beneficial use of waste materials, even biological processes. And when you talk about landfills, as a geotechs, we contribute quite a bit, looking at the mechanical stability, contaminant transport, liner systems, and cover systems. And these days, we are using a lot of biological concepts to make things sustainable. So we work on biocovers and bioreactor landfills. So in this course, I'm giving a brief, uh, lectures on broader topics. But if you are interested in knowing more about a lot of my research, then you can look into the papers that I have written. The other area of research that I work on is called life cycle assessment and sustainable resilient engineering. Here we try to quantify the sustainability and then assess the different sustainable materials, sustainable designs. So, this is really a very broad area that is applicable not only geotechnical engineering, geoenvironmental engineering, but any specialty in civil engineering, even chemical engineering and mechanical engineering, or any branch of engineering. So this is, as you know, it is becoming very important these days to look at sustainability and resiliency. It's not just talking about it, but actually doing something and evaluating, how well you are doing towards this sustainability and resiliency. So this is the other important area that I work on. And my background in master's and PhD is the geotechnical engineering. I have done all these things, site investigations. I worked in industry for 3 years, so I did site investigations, foundations. My master's thesis was on retaining structures. My PhD was on cemented sands. So did a lot of ground improvement, geomechanics, earthquake engineering, and so forth. So if you want to know, specific research projects and specific publications, go to this website, and then you can find all the information that you need. So that's what I do for my research. So it's pretty broad, but it is more on geoenvironmental engineering and sustainability and resiliency. So all the work that we have done over the years is summarized in these 4 books. And these 261 journal papers and 227 conference papers. So you can get an access to those papers from this website. So the sustainable engineering is the textbook that I use for teaching sustainable engineering. Geoenvironmental engineering is the textbook that I use for teaching geoenvironmental engineering that deals with environmental remediation and landfills and waste containment systems. So you can have a look at those things if you want to get more information. So when I do research, I follow this research philosophy. First thing what I do is I identify the real world problem. So what is that problem that needs to be resolved? And then we come up with an hypothesis of the solution that could be potentially feasible. And we test that hypothesis through bench scale testing. So we, in our lab, we do some bench scale testing. So basically small scale experiments that we do it. And if results are promising, then we scale up and do the large scale testing right in the lab. And then if it works out good in large scale testing, we do mathematical modeling. So you understand all the different fundamental processes when you do the bench scale testing and large scale lab testing, and we incorporate those processes in mathematical modeling, and we model the real world situations. If you have to do that project on a large scale, how do you do that? So we will model that mathematically. And then we actually design a typical field system, and then we actually go to the field and try to implement that and then see if it works as we modeled, right? So, it's always important to start with fundamentals, and then go systematically and evaluate that solution that you came up in a field scale scenario, right? So our research goal is, every project that we work on, we like to advance the fundamentals, but at the end, we want to come up with a practical solution. So we just don't want to look at just the fundamentals and write papers, but we at the end of our research, of course, we're going to publish papers, but we want practicing engineers to take our solutions and implement them and solve the real problem. So that really makes us very happy, because we are able to contribute to solving the problems of this society and making the difference. So that's the research approach that we follow, on projects that we work on. I do a lot of lab scale testing. So this is our lab, and this shows the facilities that we have. So we have all kinds of soil and material testing, geochemical characterization testing, geochemical testing, and depending upon the project, we develop bench scale testing. So these are all in our lab, and the students actually use all these things. So over 25 years of my career, I have pleasure of working with students from all over the world. So this kind of makes, in US, we have people coming from different countries. So, when I go to the lab, I have international, students in my lab. So it's very nice to, interact with these people, and then learn not only, doing the research, but also learn the culture, have a good time. So, for example, if you look at in the top, is from Kenya, India, Iran, France, Turkey, Philippines, US, China. So you can see people coming. She's from Iran, China, Spain, US. So you have people from all over the world coming and working. So my job is never a dull job. So it's always fun job, a fun job. Not only working with these people, but every few years we get a different group of students. So you keep working with the students, different students every few years. So coming back to the presentation, my presentation is on end use of landfills. But this is how I'm going to organize my presentation. Okay. So first, I'm going to talk about waste dumps. I know how do we deal with waste dumps? So what are the problems? So many of these things it, and then how do we solve that problem? So remediation. How do we remediate? And then once we remediate, how do we use those sites for beneficial reuse? So end use. How can we use at the end these sites? So I'm going to talk about that one in the beginning. And then, I'm going to talk about the newly generated waste. So these waste dumps are like for, the waste that was generated in the past, and that's how it was handled in the past. But now, when you have a newly generated waste, that needs to be handled properly, not, dump them in the waste dumps. So I'm going to just introduce the concept of sustainable integrated waste management. And then I'm going to talk about engineered landfills very briefly, how these days landfills are engineered. And then, once you have an engineered landfill, and once it gets closed, then, what can you use those sites for? Okay, so that's what I'm going to cover, those things. And at the end, I'm going to have a closing comments. And after that, I would love to answer any questions that you have. And just I want to, put this caveat. Since I'm in the US, I'm going to give a US perspective on all these things. So unfortunately, I don't know much about, I know some, background on what's going on in India, but I cannot be authority to say, what is correct. So I'm going to basically give you, US perspective, which is good because you need to know, what is done in US, and then you can see, what are the lessons to be learned, and how you can, do things, um, in India, right? So that's my, agenda for my presentation. So let's talk about open dumps, right? Was open waste dumps. And if you haven't seen a waste dump, I mean, if you are in a small city, you might have seen outskirts, people dumping it, or the city, designated certain area and dumping it, but you probably don't see like a huge piles that you see in big cities, right? So if you are working in this area, one advice that I have is, for you to go to one of these sites, and visit them. So, you can call up people, you can get some contacts and then say, hey, we want to come and see it. We are students, can you give us, can you show us? So it's eye-opening. You can read books, you can listen to the presentations, but you cannot get the feeling that you get when you visit these sites. And I know for a long time, I didn't have any idea about these dump issues in India. One time, I happened to visit one in Delhi. It's amazing. I mean, you can see, you appreciate uh, the problems, when you talk about these waste dumps. So I highly, highly recommend you to go to one of these waste dumps, right? And I don't know, if you have a, I'm trying to still find out if you have a MSW engineered landfills. If you have one like that, you go to that also and see it, okay? To my knowledge, you have mostly open waste dumps. So the waste dump, if you go look at it, you can take a lot of pictures, every picture looks amazing, uh, but in a negative way, unfortunately. So you see, this is one of the waste dumps. Now I want to ask you, just kind of give you, quick homework and see how many of you are actually listening to me. So in the chat box, can you write one thing, one problem with these kind of waste dumps? What are the problems with these kind of waste dumps? So can you think about one problem, and then can you type that one in chat box? Let me see. If you type it, then I know that you are listening. Otherwise, you may be doing something else. So let me see how many people will respond to my question. So what is the problem that you see with waste dumps? With your own opinion, it's not a technical question. It's a simple general question that I am asking. Just don't be shy. I'm not going to, take anything negative based on your responses. But I want to see, if whoever responds, that I know that you are listening to me. All the other ones are just probably not paying attention to. So let me see. 20 people have responded, which is great. Let me see. Okay, keep going. Don't be shy. Just type something that, what is the problem, by having the waste dump like this? Okay, very good. Keep going. So I'm seeing more responses. Excellent. Keep going. Wow, that's great. Well, excellent. Okay, I need some more responses, guys. We have more than 100 people here, so I got only like 40 responses. Okay, excellent. Some more responses I need. Yep, very good. Excellent. Some more. Yep, very good. Very good. So, excellent. Yeah, keep going. So just, this does not require any, this is not a highly technical question. Just looking at, what is the problem with this kind of picture, So this is the situation that you have with the waste dumps. Very good. I want to see some more responses before I go. Very good. Excellent. Yep. Okay. So very good. Just keep typing, okay? I want your response to be shown in the chat box so that I can see later on that you were actually listening to my presentation. So very good. Keep it going. So I just want to continue, but please type what is the problem with this thing. So there, you can see, this is not a nice thing, right? There's nothing to be proud of in this picture. So everything is, wrong that you look at it. So all the things that you guys are mentioning, they're all are, excellent answers. Okay, so just keep typing it. I need to summarize those things. But the problem that I have is people call these waste dumps as landfills. They call them, okay, we have landfills, but they're not landfills. Okay, I know landfills may be used as a generic term, but in general, in scientific literature, landfills is something. There's some kind of control on the waste disposal. But when you have open waste dump, it's not a landfill. So, which is kind of weird, because when you talk about these waste dumps, when you say landfills, people like me, coming from US and other countries may get confused. So basically, when you have these waste open dumps, probably I don't know, ground was not cleared at all, or there's no liner system, nothing. So just basically they started piling up the waste, and you keep piling up, and as the waste keeps on coming in, right? So a lot of things that you guys are mentioning, they're all problems. Like the slope stability is a problem. Allowing the animals is a problem. And physical stability is a problem. Slope stability is a problem. So these are all the problems. And as you have all these problems, we should not be having these things, right? If you don't have these waste dumps, then you are going to eliminate all those problems. So obviously you should not allow it, but that's not the case in India. So you have waste dumps, right? And the major problem with this, in addition to the physical stability, the access and all these things, the major problem is the pollution problem. Okay, so what is the pollution problem? How the pollution happens? So only thing you see is the air pollution. Sometimes these things smoke, or things get volatilized. And you have this air pollution, and that's a lot of times is visible. And then when it rains, right, all the runoff spreads all around, and it could contaminate the crops, and it could contaminate the soils, all the surroundings. And then when it rains, you have an infiltration of the precipitation that goes to the waste, and then it leaches out a lot of stuff from the it flows through the waste, and as a result a lot of dissolved constituents like toxic substances could get dissolved, and they go down, and then they enter into the groundwater, and groundwater generally flows, and the contamination flows in the direction of the groundwater. And as the groundwater keeps on flowing, some of the volatile compounds gets evaporated, and that get into the houses, the surroundings. And then, if you have a drinking water well, or any kind of a water well that you have, that could get contaminated. And then you're drawing the contaminated water. If you don't have treatment, you may be just even taking the shower is bad, because the contamination is exposed to the skin, and then contamination could have adverse health effects. If you're drinking, of course, it's going to be really bad. It could contaminate the surface water sources. And then if some of the surface water sources happens to be your drinking water sources, that's going to be contaminated. So this is a huge problem. You don't see, I mean, the picture that I showed you in the previous slide, is just the surface, right? All the random, placement of the waste. But this other thing that goes on, which you don't see, that has a huge implications on public health and the environment. I mean, you can see uh, the loss of economic loss or human loss as a result of this contamination is unimaginable. And this is not like it's happening for a finite amount of time, but it's going on forever. And these problems are going to continue, and problems become more and more. So we had these kind of problems in US before we had regulations, in the late 70s and early 80s. Then we got environmental regulations, and then these problems have been realized, and then all the waste dumps had to be cleaned up. So every waste dump had to undergo investigation, and especially some dumps may not have a problem, but some dumps may have a huge problem. So you really need to clean up under these new laws. So we used to have a small dump sites. Every city used to have a small dump. Every village used to have a small dump in outskirts of their place. And then when the new rules came in, because the new rules required, okay, you cannot have a dump. If you want to have a dump, you need to fix that dump, basically with the engineered features. And then, you really need to have a engineered landfill if you want to dump anything. So they came up with a strict regulations. So then, all these small landfills, all the waste dumps, they closed down. And that's the end of the waste dump arena in US. So in the common remediation strategy, obviously you don't want to spend a lot of money, fixing this, because these are large sites, right? It's not like a small area. You're talking about a large area. What can you do? So in most cases, you put a cap on it, on the top of it. So basically, you need to have a barrier layer, like a clay cap, so with a low permeability. So why is that? Because you don't want to have infiltration of the precipitation. So the water goes in, means that's all going to convert into leachate, and the leachate is going to spread out. All the environmental problems are going to become more and more. So we need a the impermeable or low permeable clay cap, and on the top of it you need to have a vegetative soil cover on the top of it that can support the vegetation and also control the erosion. Okay, so those are basically or you can have a drainage layer also. So you can have a clay layer, drainage layer, and a vegetative cover layer. So you don't have to really follow very strict new landfill regulations. You don't have to have a geomembrane in these cases, because this is all kind of comes under remediation cases, not like engineered landfill cases. And so the whole idea is, not allow infiltration. Also, that's the main thing. And then, you cannot have a bottom liner, right? Because there's so much waste. You cannot do anything to the bottom. So a lot of times what we do at the sites where you have a lot of groundwater pollution, so we put a slurry wall, basically these vertical barriers all along. I mean, you can put it all around, or an up gradient or down gradient. There are different configurations that you can create. Most of the times these extend into the impermeable layer here, as you see. And so any leachate that is created is infiltrated down into the aquifer. That's going to stay here. And then you don't want to have accumulation of water below this slurry wall. So sometimes you have these pumping wells to extract that accumulated water and treat it. So you want to have a system which is cheaper, and you don't want to have a very active system where you have pumps and other things going on all the time. So you want to have a passive system. You want to build it and walk away from there, with minimum operational conditions. And then if the waste is not fully degraded, then you need to have a gas management system. So gas management system, I gave you a lecture on this one the other day. So you can have some extraction wells or trenches, or you can, if gases are not that much, the flux is not that much, you can actually have this clay cap. You can amend with some organic material, like we do. We amend with biochar, so we call this biochar amended soil cover, and then you can mitigate the gases passively within the cover system. So you are eliminating all the stuff. So that's how these are cleaned up. And then once you clean up, once you put a vegetation on the top of it, right? Then this looks, it can convert as a park. Just most of the times you see this, the end use as a park is the cheapest option, right? So of course you need to grade the elevation and everything, and then so you have this kind of, this is one of the landfills close to my area, and yeah, and people go there, and of course it's high, right? And then from there you can get a good view. But there are other end uses possible. I'm going to talk about those things later on. Even those end uses are possible on this closed dumps, and as well as engineered landfills after their closure. So I will explain those things later on. But this would be the simplest end use as a park, and of course you have a soil cover and everything, so there is no exposure issue to the people, so people can go there and enjoy this park. And as I said, so you have a mountain, so the top view would be like a prime spot to look at surrounding, and people can go there. On the other extreme is the mining. So the mining is basically digging it out and screening, separating these things. But mining is done only when organics is mostly degraded. If you have organics in there, generally it's not done. The other thing is the residue after organics is degraded. The residue should be clean. It should not be contaminated. If it has a lot of heavy metals or other types of semi-volatile organic compounds and other things, then that this mining becomes very, very expensive, because you need to address the contamination. Most of the times in the US, mining is done at some places, not that much, but very few places, and mainly because the waste dump had to be cleaned up, but then the area needs a place to dump the new waste. So most of the times this mining is done to create a space so that they can have a lined landfill. So, but there are very few cases. I'm going to show you one case, later on in my presentation. But the decision is based on cost-benefit analysis. A lot of times it becomes very expensive to do the mining, and the value you get out of mining, with the resources that you recover, is not that much. So just so I wanted to mention that one. In the US, that's the status. In other countries like in Europe, it could be different, but in US, most of the mining is done in areas where they wanted to create a space for engineered landfill. So basically they are digging out all the degraded waste from old landfill, and then using the same space to build a engineered landfill. Now the question is about newly generated. Okay, that's about waste dump story. And that's the story from US point of view. So you learn the lessons from that, and then see what can be done in India. Now the question is about newly generated waste, right? I mean, we are creating the waste, every year, and the waste that is being generated is increasing because the population is increasing and so forth, right? So if you have dumps that are existing, and if you are not solving the existing dump problems, if you keep on piling this newly generated waste on the top of the existing dumps, when are you going to solve the problem, right? So the waste dumps problem is going to keep on increasing. And this is a tremendous amount of waste that is being generated. And as I understand, this waste is still going to the dumps. So if you're trying to clean up the dumps, if you keep on adding these things, the problem is not going to go away, right? Think about it. It's not a rocket science, but just think about in very practical terms. Okay, if I'm generating so much waste, per tons per day, so it's like a Delhi, 8,700, Mumbai, let's say 10,000 per day, right? Even if you assume 50% processed out of this, so 5,000 per ton, 5,000 tons per day, right? So, you can add up, every day that much. So per month, how much? Per year is how much? So you still need to, accommodate that waste, somewhere. So if you don't have an engineered landfill, obviously, you are taking to the dumps, and, the dump situation is going to become worse and worse. So young guys like you guys to think rationally. Also this, all the stakeholders that work on these waste management issues, they should really come together and think about what is the long-term solution to this waste problem. So we have waste dumps, and we are creating, this new waste every day, right? So we need a comprehensive solution to this problem. So this is, very challenging issue, and very important issue for researchers. If you're a student, master's or PhD student, if you can do something in this area, you are really, helping people, helping the planet. So if you are passionate about environmental issues, this is the one that can really make you happy. So question is, what can be done, right? So what is the big picture? What can we be doing with the newly generated waste? What is the rational way of doing it? So I want to show you this picture. So this is called, integrated waste management issue. So remember, you probably have seen, waste management hierarchy, but the waste management hierarchy does not work in real world. So this is called integrated waste management strategy, where you're going to collect and sort it, and then you do the material recycling, and then some biological fraction you want to, treat it by composting or anaerobic digestion, and then, whatever is possible, you want to, treat it thermally with energy recovery or without energy recovery, and also, things that you cannot do anything with any of these other options. So you can landfill it, and not landfill here is, you're talking about engineered landfill, not the waste dump, and you can actually make that landfill as an energy resource. So landfill gas use, you can do it. So what I'm trying to say is, a lot of times people argue that, okay, we're going to use the thermal treatment and make the waste disappear. That's not going to happen, because there's a certain amount of waste that is not amenable to thermal treatment. Or, you want to do the biological treatment. Not all the waste components are amenable to these biological treatments, right? Not everything could be recycled. So the idea of integrated waste management is that we need to use these combined options at the same time. So don't think about like, okay, I want to emphasize this more and emphasize this less, but look at your situation and come up with a combination of these options. So you want to have a material recycling, biological treatment, thermal treatment, if possible, and also landfill. So you need to really think about, this framework of, using all the options that you have, to benefit the situation that you have at hand, right? So this is called integrated waste management. Now, question is, okay, I'm in a city. So obviously, yeah, I cannot do the 100% recycling. How much I should do the biological treatment, how much I use the thermal treatment, how much I should landfill. That really depends upon the sustainability factors. So you really look at that integrated waste management from sustainability lens. So this is what I mean by that. So what you have to look at it, okay, this is the integrated waste management strategy that you have in the middle, right? That's what I showed you before. This, I hope you can see my cursor. So that's in the middle, right? Then how much of each option that you have to use in a given situation, that really depends upon economics, okay? What is economically, feasible? And then environmentally, what is the best way to do it, So obviously you're trying to create a better environment. But if I have a thermal treatment and if I have a other secondary environmental negatives, then that's not good. So you need to look at the broader environmental impacts, broader economic impacts, and then you need to also look at the societal issues, right? Community issues. So obviously, you need to give them food first before you think about spending a lot of money on this integrated waste management. So you need to look at, you need to really, really think about, people, in that community, what their, social requirements are, survival requirements are, and, you take care of the social needs first, and then in the context of those, what can be done in this, right? So this is kind of a best framework that you can apply. Whatever you do in, for example, in a big urban city, for example, Delhi, could be different than, small city where you live, right? So you cannot impose having engineered landfills every location, or you can have thermal treatment, every location. So, for example, I come from a small village in India. When I was growing up, we didn't have landfills, we didn't have thermal treatment. We in the house, we used to sweep, and we used to have all kinds of waste that we generate. We used to go, and I remember outside of my village, we used to have a pit for each family, and that the people used to go there and dump in that. So basically, we were doing anaerobic digestion there, and we do throughout the year. I remember during the summer times, we go there and dug it out and spread it in the farms. I remember, that was my very, very childhood days that I'm talking about in the village, that we do it. And zero waste scenario, right? And we didn't need thermal treatment, we didn't need land. So that's what I'm saying. You just look at, this is scalable from, village to small city to large city, right? So this is the framework that people are not grasping. People want to do one thing. The reason why it's not grasping is you need to have this multidisciplinary background to address this waste management issue in a holistic way. Okay, this course, I can spend a lot of time on this one, but this course is focused on landfills, right? Waste containment system. So landfills, is not a rocket science anymore, okay? Because we have in the US, we have regulations, we have, people follow the same kind of design everywhere in the world. You have, bottom liner, you have a side liner, you have a leachate collection system on the top of it, then you pile up the waste, and then you have a final cover. We have a well-established, materials and design methods for liner systems, leachate collection systems, and then final cover system. So this is, people are doing it. In the US, we have been doing it for, over 30 years. And we designed the landfills, as per these procedures that we have, and they have been monitored, and they are working good, right? So it's a proven concept, proven design analysis methods. So not only the bottom liner, leachate collection systems and the final cover system, all these landfills will have a leachate collection and the treatment, okay? That's the important issue, because the main problem with the landfills is the leachate that needs to be addressed, and also landfill gas, right, that comes up. So what do you do with that one? You collect it and you treat it, or do something with that one. As I mentioned in my last lecture, there are many options for that one. You can create the energy out of it, right? Which is good. So this landfill is not a waste thing. You're creating, that's like an energy source that you can really capture that all the energy. And then in addition to all these things, you need to have a groundwater monitoring system. So basically you put the wells away from this landfill, and then constantly, periodically, you will collect the samples and monitor it. Why do you do that one? You might say that, okay, I designed this landfill perfectly and it's never going to leak. But what is the guarantee? How do you demonstrate that? So these groundwater wells that you have all around the landfill, you keep monitoring it. Okay, if it's normal water, then no issue. Suddenly, if you see some contaminants showing up in this one, especially if it is in down gradient direction, and then you have to be really worried that this landfill may be leaking. So you get into the detective mode and figure out if if this landfill is causing that leak, or it's causing, causing contamination. So before it spreads too much, you want to address that problem, right? So that's the purpose of these monitoring wells, that guarantees that your design is working properly. So we do these things, routinely in the US. So as I mentioned, there are a lot of resources that you can use to design these landfill components. So, we wrote this book, and my co-author has like over 40 years of practical experience. And I also worked for 3 years in industry. So this book, whatever is there in this book, that is not hypothetical. It's all what is actually being done in practice. So I know this book is expensive. We talked about this one a little bit before. Make sure that your library or somebody who can afford it can get it, and look at these chapters carefully. And I like the way these chapters are written, because it's a logical sequence of topics. Because when I took landfill class, when I was a graduate student, my professor came suddenly, first day, and then he started talking about liners. I had no clue what we're talking about it, because first of all, you need to know what are the sources, characteristics of the waste. Are you dealing with MSW landfill or hazardous waste landfill? What are the regulations? How do you locate the site? What are the liner systems? So you need to build gradually. Even within each one, when I say liner systems, you need to, again, think about where do you start. Okay, I'm not going to start about something, but what is the logical way to start working on these things? So that's the idea of writing this book, is to give a new reader or new engineer, or the students, to give this sequential topics, and at the end you end up with a engineer landfill that works. So as I said, all the landfills in US, or we don't have any dumps. Okay, the dumps are not allowed, so we have engineer landfills. So here is the liner and leachate collection removal system construction. There are waste companies. The landfills are owned by private people. The way they get the money is, whenever the waste comes to the landfill, they have to pay for that one. Most of the waste is handled by the city governments. For example, I live in a place called Naperville, and Naperville actually, taxes me every year some certain amount of money for the waste, and then every week they collect the waste from me, and then they send it to the landfill, and they pay to the landfill. So the landfills are owned by private people, and they make money because they are charging, people who are bringing the waste to their landfill. Per ton is how much, whatever they charge, right? So we have, these private landfill owners that they do it. And then in terms of the design, we have a lot of private companies that they do, consulting companies, engineering companies, they just design these landfills. So, for a given situation. So the practice is well established. So, this is, I've been to many landfills. So again, as I mentioned, you really need to go to landfill. When I teach a landfill design class in my university, I make sure that we take students to the landfill, and then have the landfill operator give a tour of the whole landfill, and they really can put things that they learned in the class into context when they see everything. So you place everyday waste, and then you compact it with these compactors, and every day you cannot walk away without putting a daily cover, and next day you come, and then if it's a removable daily cover, you can remove it and put the waste, compact it, that keeps on going. And at the end, when you put the final cover construction, and then what is the end use? I mean, this lecture is on the end use, and this is the end use of one landfill after closure. It's converted into golf course. It's again not too far from my place, and it's they're making money because all the rich guys come to play golf course, and they pay a lot of money to play, and this is there's a revenue source. It's just not a, and it's aesthetically looks great, right? So you can see that. And then remember, the landfill requirement says that after you close it, after you put the cover and you put the vegetation, you need to monitor for 30 years. What are you monitoring? You're monitoring the leachate, gas, and the groundwater monitoring. That has to be done for 30 years. And during the landfill operations, the money is taken out from the landfill owner and put it in the bank. And then that money is used every year to monitor the landfill. So if there is any issue, then they need to get into detection and correction action mode. So this is what goes on. I mean, you're using it, and at the same time you're monitoring it. There are no issues, and then the problems will continue to exist until the waste is stabilized. Waste, what do you mean waste is stabilized? Until the organics, entire organics is degraded within the waste. So coming to the end use of closed landfills, once you have the final capacity reached, and once you put the final cover, and then you monitor for 30 years, as I mentioned, this is required as per the environmental laws and regulations. And then that site can be used for different purposes. So park sites, one thing, common thing, and nature centers, recreational centers, golf courses, commercial buildings. So, you can use for a lot of these different end uses. Unfortunately, what happens is people don't think about this end use in the beginning of the landfill project. So they think about this, oh, what could we use after closing the landfill? So they think about it after the landfill has been, in operation for many years, or when it is closed. So that time you have less flexibility, right? You already decided what the geometry is going to be, the final cover. If you knew in the beginning, then you could have changed certain things. It would have made it much easier. So the end use is important. You just don't want to walk away from the site and leave that large area of the land, useless, right? So you want to use that area for some beneficial purpose. So the end use consideration improves the aesthetics of that location. So here in the US, you go to a closed landfill, you don't even think it is a landfill. There's no smell. You don't even somebody has to tell you that, or you will see these monitoring wells around, then you will see that it may be a landfill. But otherwise, they are very nice locations to see it. Okay, nice sites. So they look pretty nice. And then, as I said, especially if a site is in an urban location, and urban areas, land is scarce, and so using it even as a park in the middle of all this built-up area is really nice, right? So that's what I'm saying. And so those are the benefits, but there are a lot of challenges. You're trying to build on the top of the waste, right? So think about it. Building on top of soft clay is a problem, right? So the problem with building on the top of the landfill is you're going to have a substantial settlement, also non-uniform settlement. So that's going to be a big problem. Okay. And then, the waste is degrading slowly. So you're going to have a landfill gas emission problem. So that we have to worry about it. And the leachate outflow. So leachate is going to be, needs to be addressed. So these are the big problems that you don't see in typical, infrastructure development projects, right? But still, landfill sites after closing are used for different purposes. So the common purposes are these: methane gas energy generation, solar energy sites, or reopening after closure, mining, recreational uses, and commercial and industrial uses. So these are all the different uses that have been actually practiced in the US. So what I'm going to do is quickly give an overview of each of these things. Okay, methane gas energy generation, right? So as I mentioned, as the waste degrades in the landfill, you're going to have 50% of methane in that landfill gas. So that has a lot of value. So heating value is 500 BTU, off of natural gas. So it's not bad. And landfill operators can sell that gas or use it for energy recovery. So what you do is you collect the gas from the landfill. You have to put those gas collection wells anyway. And then you basically pump all that methane through the gas scrubber, and then gas compressor, then finally the engine generator to generate the energy. So this is also promoted by US EPA because methane emissions, as I mentioned, landfills emit a lot of methane, and that is a huge greenhouse gas contributor, right? So methane is 28 times potent in terms of the global warming compared to CO2. So it's anything you can do it's good. So US EPA has a program to reduce the methane emissions, and they encourage these kind of things because now you're not emitting to the atmosphere, and then you're using the energy, and equivalent fossil fuel burning is avoided. So you have double benefits on this one. So this is the landfill, which is about 150 kilometers from, it's like 100 miles from Chicago. This is where the waste of Chicago goes. So we don't have any small landfills in the US. We have a mega landfills. These are like outskirts. I'm talking about from city of Chicago. This is 150 kilometers. So all the waste that is collected, and they go to the transfer stations, and then from transfer station it loaded into the trucks, and the trucks transport this one to this landfill. So that's the case in most of the entire US. So you have these mega landfills outside the cities, and then the waste from the surrounding cities goes into this one. So this is called Livingston County Landfill, Pontiac. This is where I take my students when I teach landfill class. So as you see here, this is the waste mound. This is also waste mound. This is the gas extraction well. You have these pipes, and the pipes go into this, the gas to energy plant that you see in the background here. See this one here? That's the gas to energy plant that you see, and it generates the electricity for 10,000 homes for the city of Pontiac, which is close to this landfill location, which is great, right? So this is the kind of end use that you're looking. So this will continue. This project will continue until the gas is completely exhausted. And then this landfill sites can be used as a solar energy sites. Huge open area, right? If you can put solar panels on those areas, you're creating a lot of solar energy. For example, in the US, this is the US map. Everywhere across the US, you have solar energy potential. This shows red means more sunlight, so more energy. So I'm in Chicago. It's right around here. We are in like a blue. Not as much as some western part of the country, but still, no matter where you are, you have a potential to generate the solar energy. So this is the landfill, at a place called Conley, Georgia. So this is the landfill closed, right? So they put a final cover on the top of, they reach the capacity, and then so it's closed, and then what is the beneficial end use? So they put solar panels on the top of it, right? Also, they used a unique cover system called exposed geomembrane solar cover. They have like a 7,000 solar panels placed on that one. And think about it. This is the open and no obstructions, and you could get the maximum efficiency out of these things. So which is excellent, right? So that you can do those kind of things anywhere you want it. The other end use is reopening after closure. This is not an end use, but this will happen sometimes. So you close the landfill, you have existing landfill, and let's say you created a new waste and you don't have a landfill where to dispose of. What do? Right? So let's say you close the landfill, and then you have this new waste, and I cannot find a new landfill location. And what will I do? What should I do? So, if you don't have any other option, maybe it's a good option is to expand the existing landfill. So this is called a vertical expansion. So you're putting on the top of existing landfill, right? You see here. So when do you use this one? Because if you don't have too much of area, you own only this land. This is the property boundary. This is the property boundary, and the only way you can expand is going up, right? Not laterally. So that's what is being done. So it makes it challenging because at the edges, okay, original landfill had stable slopes, but now if you want to increase it, you need to have a retaining systems around it. Otherwise, it's not going to be stable. That steep slope. So now there are a lot of reinforced retaining wall systems. Because if you don't have to have a retaining wall system, you just want to have a perimeter berm, right? So you will occupy so much of space. This is the boundary. You cannot go across that one. And then when you put a conventional, earthen berm, you occupy so much space, and you will have you lose the space for the waste. Whereas if you put a reinforced retaining wall, so the space that is occupied by the retaining walls is a retaining wall reinforcement, backfill is here, and then behind that, you can have a large area. So same thing that you can compare here. You can have more space for more waste to be disposed. So a lot of these cases, reinforced retaining walls are becoming common. In the back of that one, you need to put the membrane and then expand on the top of the landfill. So these projects are being done. So this is the where you have the area is limited and you can only go up. But in some cases you may have area available right next to existing landfill. So this is called lateral expansion. So you can expand laterally. So this is how it is done. For example, this is the landfill location, and there's nothing around that area. So we could basically have a new cell right next to the existing. So this is the existing landfill, let's say, and then you can have a lateral expansion on the right next to it, right? So that's the other thing. So it was closed, but now you realize that you need to accommodate more waste. So this is the lateral expansion you can do. Put the liner systems and everything, and then make it a bigger land. The other one is the mining. Mining is basically you want to recover the goods, and also, as I mentioned before, mainly in the US, it's done to create more airspace for putting more waste. So basically, if you're running out of the space, and if you cannot do the vertical expansion or lateral expansion, so what is the best way to do it? Then take out the waste and mine it and create more space that you can put the more waste in the same landfill. So you use the surface mining technologies, excavation and separation. There are different steps. You split them, and metal separation, and then screens, and then wind sifting, and basically you get separate these metals and oversized particles, heavy metals, heavy materials, and light materials, and the fines. So you basically excavate the waste, and then transport it, and then here is the excavation feeding into the conveyor, and you have a magnets that is taking out the iron. Here are the shakers, and you shake it, and then so you separate the oversized versus finer fraction from that waste. So that's what is done. And then just an example, this is the landfill in US, where they try to do it, the phase 1, just to see how this whole thing works out. Phase 2 was supposed to start in 2019, 2020. I don't know the status of that. So the idea of this mining at this site is there was an old dump without any liner. This is a huge landfill, and there's a portion that's was not lined, and they wanted to there's to prevent groundwater contamination and greenhouse gas emissions from there. So they wanted to also create more space. So they wanted to basically mine that old landfill area, dump site area, and then recover the materials and create the space, and then use the soil for the new landfill construction at the same location. And economics wise, it's expensive, but they didn't have option to look at it because how do you clean up the contamination at the site? So it's a constant source, and it's emitting the greenhouse gases. So to control the environmental pollution, they had to do this mining. This is another landfill that is mined. The problem here is that they had this landfill, and it's reached its capacity. They were thinking about having a new landfill at somewhere else, but it didn't work out. And they did all the cost benefit analysis of maybe having a different landfill at other locations, and what are all the options that they have. They could think about that. Finally, they found out that mining is the best option. So you mine it. You're mining it to create a more landfill space to accommodate the more waste. So here it's a lined landfill. It's an engineered landfill. The waste is in there, and then basically the waste is degraded, and then you're using it the same location. So There's another project in the US. This is a research pilot study, and they did some investigation. They found out that doing the mining is not economically feasible compared to the other options that they have. So they abandoned the project. They terminated the project after they did the initial investigation. So recreational uses, this is very common. Golf courses, all these things, nature, recreational parks, animal refuge, tennis courts, sliding hills, ski runs. So this is one landfill in Florida. You can see this is all the entire landfill. So you have hiking trails, you have baseball stadiums, you have basketball courts. So, this is the place that people want to go more often, right? So, some people may not realize that this is a landfill. So this is the recreational use. And I showed you this before, this close to my house, in the Chicago area, and it's a nice golf course. So this is the landfill that's converted into golf course. So when you're thinking about these recreational uses, capping is important thing, right? So erosion, infiltration, and you need to also think about landscaping aspects and trees and landscape. You need to think about, what kind of trees, what kind of vegetation that can grow on the landfill cover. And you have to think about the settlement. So the settlement is going to keep on happening. You're going to do the maintenance, but you don't want to put anything permanent. So you want to put non-permanent flexible materials, and then you have ongoing, maintenance. And then last one is the commercial and industrial uses. On the top of the landfills, again, other people have mentioned, in those days, the landfill locations used to be outside the cities. Now, they are within the city, within the center of the cities. So those are the ideal locations to have retail stores, warehouses, office buildings, right? Manufacturing facilities. So they want to use these locations for buildings, constructing the roads and parking lots. So this is one landfill where they built this building. It's a Home Depot. This sells all the materials that you need for constructing the homes. Okay, what did they do? It's an unlined landfill. So there was no liner at the bottom. So they use the pile foundations to support this structure. So the piles go all the way to the bottom of the waste and then into the subsurface soil. And they have an active gas control system in this one. Here is another location. It's in Coma, California. And then again, this is also like Home Depot. This is the famous store to buy a lot of stuff relates to house. And here they did, before they built this house, they put a site surcharge load, and then they used the hinge support slab connections for this thing. So you have to think about how do you control the settlement and other things. And this is another location. There's a landfill, and that landfill is converted into an office building, right? So this is the situation. But you need to think about the challenges in designing these things, right? Designing the building on a problematic soils is a complicated thing. But if you're trying to design these things on top of the landfill, it's quite complicated. But nothing is possible for engineers. Engineers are there to create the solutions, right? So the settlement, slope stability, gas generation, leachate collection, drainage, we need to consider these things. So settlement and slope stability you do always, but we need to consider this additional gas generation, leachate collection that never happens in typical cases. And also constructability and health and safety construction personnel. So you're working in the landfill during the construction, so you have to be careful. And you also think about how the construction will affect the containment facility, because you don't want to compromise the containment efficiency, and how the landfill environment will affect the infrastructure components. For example, if you have pipes, piles, foundations, you're putting them in the waste, how would they get affected compared to putting them in the soil? So the settlement is a big issue. So like in conventional geotechnical engineering, we use the surcharging, dynamic compaction, grouting. So those can also be done. Dynamic compaction is commonly done. But the other option is leachate recirculation or bioreactor landfill. So what it is basically you have a landfill, and this can be done only in the lined engineered landfill. So you need to have a liner system and leachate collection system. If you don't have that one, you cannot have a bioreactor landfill. So it's called bioreactor landfill or leachate recirculation landfill. So if you are just circulating the leachate only, that's called leachate recirculation. Bioreactor landfill kind of, is a broader term to imply not only leachate, you could, inject other kind of fluids, other kind of amendments in it. So you take out the leachate and then you inject into the waste, and through vertical wells or horizontal trenches. Basically, you increase the moisture content. The problem with engineered landfills these days in the US is that you are putting the cover on the top and you are taking up the leachate from the bottom, so the waste tends to be dry, and under dry conditions it does not degrade well. So the whole idea is to recirculate the leachate so that the waste moisture content can be higher, and then waste can degrade really fast. So it has a lot of benefits just doing this one. So there are primary benefits and secondary benefits. The waste degradation happens really fast. You can get a lot of gas right away. Waste to energy projects are possible. Settlements happen really fast, and ultimately you're trying to achieve the waste stabilization quicker. And the secondary benefits is, since you are leachate recirculating it, so you're not spending money on leachate treatment, and then you're stabilizing very quickly, so you're going to reduce the post-closure costs. And then once the waste degrades faster and settles, then it's easy to construct anything on the top of it. So relatively, so end use becomes a lot easier. So this is like an in situ bioreactor system. So it's anaerobic bioreactor. If you are familiar with biotreatment systems in environmental engineering, this is like a huge anaerobic bioreactor, in-ground bioreactor. So we have been working on these bioreactor landfills for a long time. So maybe for the last 20 years we've been working on these things. So I was looking at my publications. I have more than like 30 publications on this one. One of the publications is in IGC, in Indian Geotechnical Conference, in 2006. That was, calculate how many years ago, 15 years ago I was talking about this one. And then we did a lot of lab testing. This example of that paper. I didn't put all the papers, just selected a few papers and put those things. And then we did also a lot of field investigations, like a geophysical testing and other things. So I really want you to kind of, go, all these publications are available, on my website, and then you're more than happy to look at that one. And then we did also, did modeling and then created design charts, right? You want your research to be used by practitioners. So we created the design charts. And then recently we developed a very comprehensive coupled thermo, hydro, biomechanical model, and to predict how the landfill, bioreactor landfill will perform. So I really, that would be the state of the art modeling paper. So you can have a look at it, if you're interested in working in this area. So this is kind of a very complicated situation, because you are, injecting the leachate, how the leachate gets distributed, based on that, biodegradation happens. When the biodegradation happens, you could, change the temperatures. Temperature will affect the biodegradation, and biodegradation changes the solids, and then that affects the mechanical properties, and all properties of the materials will change, including the hydraulic conductivity, and the leachate gets leachate, distribution will change. So these are like, you have a thermal, biomechanical, and hydraulic processes. All of them are interlinked. So if you are looking for a challenging, research problem, this would be, one of those problems. So we did this modeling, and then we were able to predict, in a given bioreactor scenario, what will happen to all these things that we are interested in learning. So, but you need to look at the gas generation. So you need to have an active or passive gas control system. So let's say you want to build a building, but if you don't collect the gases, they are going to appear everywhere, and it's going to create stability problems, but also health problems. Leachate issue also is important. You need to collect the leachate, and also runoff issues that you need to look at it, and slope stability issues, right? You need to look at not only the applied forces, but also any gas or leachate pressures that are generated in this one. So you need to think, in a clever manner. For example, here I'm showing you want to have a slab like this one. At the end of construction, at the end of settlement, you want to have this profile. So you build it this way. So you build it, this like a slope that I'm showing here. So you build it, like I'm showing on the top, and then when it settles, when the waste settles, and it will, finally come to this configuration. That's what you want. When it rains, you don't want the drainage to go towards the building, right? You want the drainage to go away from the building. So you need to think about, how the settlement is going to take place, and then we'll design that one. Pipes, you need to have these, adjustable, flexible connections so that they can elongate, compress. So that's important. And the foundations, when you put it in a landfill cover, you need to design as based on the fact that you have a solid waste below that, and that can be done. It's done. It's a grid foundation or a mat foundation that has been designed. And sometimes you may have to adjust the landfill cover thickness to accommodate this one. And the piles have been used extensively in some of the old landfills to support higher loads. But you need to take into account of the negative skin friction, downward drag loads, and also you need to figure out how to reduce the down drag, and also any kind of environmental compatibility issues that you have. You can look at that. So I've taken up time. Just a closing comments. So we must, I hope I convinced that waste dumps must be properly closed out. You cannot keep on putting more new waste on that, and that these problems are going to persist for a long time. And the closed dumps may be used for different purposes. Mining is possible if waste is stabilized, and cost-benefit analysis shows it's favorable. Newly generated waste should be managed as per sustainable integrated waste management strategies. And then you need to have engineered landfills as a part of that. And design of landfills is well established. So you don't, we still do research on landfills to make these landfills more efficient and inexpensive, but the standard design procedures are already there. There are many end users that are possible. So that's the point of my presentation is. And these end users poses challenge, especially if you are trying to create commercial buildings on these things. Some places they want to go and build buildings because those are the primary locations. So even if it costs more, even if it requires constant maintenance, they want to do that. So those are the examples that I mentioned. So in the end, I want to mention, if you are working on landfills or waste management issues, I highly recommend you to have a glimpse of this book and have a glimpse of these chapters. I cannot overemphasize the need for this one. This book is written mainly to avoid that confusion for first-time learners on how to do these things in a systematic way, and each one how you do it in a systematic way. So you won't be regretting, if you get a chance to look at these things. So I'm done with that presentation, and just I kind of want to do some advertisement on something else. The advertisement is, I organize an international webinar series on every Friday. Today is Friday, right? In India. So 9 a.m. Chicago time, and in India it's at 7:30 p.m. So every Friday, 7:30 p.m. in India, we have a webinar, and this deals with the different topics in geoenvironmental engineering. These are not like the general topics. These go into in detail the technical aspect of one research project. So you really get, these are technically rich projects. So this is the schedule for July, August webinars. So tonight, your 7:30 time, if you are free, I would highly recommend you to attend this webinar. This is dealing with compost and vegetation using along the highways, roadways, so that we can do the erosion control as well as increase the stability. So, and there are other webinars as you see on different topics which would be very interesting to attend. So you can go to my website, and then you will find all that information related to my publications and my research and other things. And I would love to be in contact with you, in case if I don't answer the questions. I am on Twitter, Facebook, LinkedIn, and this is my email. Try to contact me. So don't hesitate to ask me any questions that you have. So with that one, I know maybe we can have a little bit of time to discuss any questions that you have.
Yeah.
Mm,
There
yes. Thank you, sir.
Yep, go ahead.
Sir, this is Chandrima Bhotro from India. So can I ask one question to Sir
Yeah, please
Professor Reddy? Yeah,
go
thank you,
ahead.
sir. Sir, first of all, I would like to thank you for such an informative presentation. Sir, actually, I'm working on this landfill waste only, and my work is related to landfill liners. So, sir, one question I just want to know is that, actually, I'm working on a landfill which is already existing landfill, and which is non-engineered landfill. So, means the liner which I have already designed, how we can implement that liner in an already existing landfill? That is my question. Means, which is a non-engineered landfill, but if we want to implement that liner, or I'm working on a amended clay liner. So, sir, what is the procedure, or is there any procedure in that? Means, how can we develop a non-engineered landfill into an engineered landfill?
So as
Already,
as I as I told you that I give you an example of that one. One example that I gave you. There's nothing you can do. To put a liner under an existing
yes,
waste. So the example that I gave you, at that site, they had this waste dump coming from the past, and then they had a new engineered landfill right next to it, and that old dump was creating a lot of problems for the groundwater, and they would
yes,
needed to
sir.
spend a lot of money for that one. So
Yes,
what they had to do is, which is only feasible, is to take out all the waste. Basically, they dug it out, and one good thing about that situation is that that the waste dump has been there for a really long time, and then they did BMP test, and they found out that waste is almost stabilized. So they took out all the waste, and then they did mining, and then they created this new space, and then they put a new liner system and accommodated the new waste in that. So so you cannot do anything, to, if you have a huge pile of waste that existing already, you cannot, how can you, go to the bottom of it and then put a liner system on it? But in terms of the barrier systems that you look at it, there is like a bottom barriers. That's a different game, just creating an impermeable barrier, below the any existing structure that you can do it. But for a typical compacted clay liner or compacted soil liner or amended soil liner, you cannot do anything. That's why you have to be extremely careful in designing the bottom liner system compared to the final cover system.
okay, sir. Okay, sir. Thank you.
Thank you.
Yeah. So anybody, please unmute yourself and you can ask a question to Professor Reddy.
So can I ask one question?
Yes, please.
Yeah, good.
Yes, sir. Sir, I just wanted to ask that, like you talked about the mining of the waste, but in Indian scenario, as you mentioned, that a new waste is already coming on top of it, and the waste that is on the bottom of the dump, that we can mine it out because it has maybe stabilized a little bit. So how do we deal with this situation? That, like, if we dig out the bottom part of the waste, there will come slope stability issues. So how do we tackle with this problem?
Yeah, I think, basically you have to be diligent about that one, right? You need to develop the engineering plans, to, to ensure the slope stability of your excavation plans and everything. So that has to be done very carefully, very diligently. So yeah, that could be possible. The old waste that has been there for years, that could have been already stabilized, so that could be mined. And then that mined areas, if you are starting to fill with a new waste, you don't want to create the waste dump again. So
Yeah.
you want to create this mined areas as like a new cells where you can actually construct engineered liner systems and leachate collection systems, and then you start dumping the new landfill. So that could be feasible. But if you are not, if you don't want to have a landfill, the idea that I hear is that you want to remove all these dump sites and make it as a useful land. The question is, you should stop dumping the new waste there, right? I mean, otherwise this problem is going to exist forever. And the second thing is, by miracle, if you take out even all the waste, the underlying soil and groundwater is contaminated, and in US, nobody will allow you to build, residential structures on a contaminated site like that. So there should be like a careful planning of, proposed mining activities and the newly, generated waste dumping, and then how do you address the environmental issues related to air pollution and then leachate and those things. So you have to look at holistically everything in detail. So you need to have a background on like more environmental side and geotechnical sides. That's why I love geoenvironmental engineering, because in geoenvironmental engineering you need soil mechanics and rock mechanics, but also you need hydrogeology, geochemistry and microbiology and all those things. So if you have a little bit of understanding of those things and work with multidisciplinary specialists, then you can come up with a very comprehensive solution to solve the problem holistically. Okay, did I answer your question? I think.
Yes, that's fine. So, one more question?
Good morning, sir. Can you hear me, sir?
Yep.
We have many questions in the chat box as well.
Hello.
Yeah. Yes, Sujay.
Yes, please.
Yes, sir. Good morning, sir. Sir, I have done my MTech from IIT Kharagpur, and presently I'm working in Coal India Limited, sir. And I live in West Bengal, sir, nearby the banks of River Ganges. So, sir, here it's not about a technical question. I wanted some, some light on a problem that we are facing in India. As India is a developing country and US is already a developed country. In India, I have seen that the place where I've been living, sir, just behind my residential colony, there has been a landfill which has developed for the last 6-7 years, sir. And the river Ganges just flows adjacent to that landfill, sir. So what happens is, due to the construction in the space for building new buildings and all, sir, some people even come and build these small tents on the landfills. But the landfill has not yet been closed, sir. And people are still dumping, the municipal corporation is still dumping their waste into the landfill. And sometimes when the high tide comes in, sir, the high tide takes the waste with it into the river Ganges, sir. So, sir, is there any way to stop this and to make the people out, to make the government aware of this kind of problem, which is not only, sir, affecting the river bodies, but is also affecting the land, and is also affecting the structural components of the residential buildings as well, sir?
Yeah, that's the the problem that you described is has a lot of environmental implications on public health as well as the environment. Especially you're talking about water resources and other things. So people don't realize that one, because the effects are not seen immediately. So all this environmental impacts will take some time. But it's proven that even dump sites in Delhi, the population around that have got a lot of health issues. I mean, it's well documented. So I want to say all the things that you described. If you are an environmental engineer, that's like a nightmare. You don't want to.
Yes, sir.
You don't want to have those situations. First of all, you saw that I showed you the solid waste rules of 2016, and that
Yes,
clearly spells out where to put landfill. So If it is adjacent to Ganges, that's not the right place where the landfill should have been. And if it is a dump site, the problems are really concerning. And if you are saying that they are still dumping, that's concerning. If you are saying that people are, living in that area, it's concerning. So there are a lot of things that are not, it's sad. I just can say that. But as a geoenvironmental engineers, as environmental engineers, as geotechnical engineers, if you there are solutions that could be implemented, but that need bold decisions. First of all, how do you stop dumping new waste on an existing dump that is posing a lot of problems already? So you're never going to solve that problem. You are aggravating the problem. So how do you make that things happen? So if you have a new waste, what are the solutions? Where do you put that one, right? So you need to think about holistically. You need to close the dumps, and then you need to have engineered landfills that are located in such an environment where public is protected and the environment is protected. So you need to take some bold decisions, and you need to come up with a comprehensive plan, not one thing, but series of actions that can be taken to address all the issues. And sometimes it needs education to all the stakeholders. Hey, you're doing this one. Whoever has the power to make the decisions, they need to be educated on the issues related to all the environmental issues related to what is going on. And that we need environmental champions, and education of the stakeholders to get those things. When I hear those things, those are the things bother me. A lot of research that we do are to avoid those kind of problems.
Yes, sir. Thank you so much, sir.
Yeah, you're more than welcome to send me an email, and we can discuss that one more detail.
Yes, sir. A letter has also been written to the regional office of the Ministry of Environment, Forest and Climate Change. But still, under their jurisdiction, they could have done something. But still, sir, the landfill is not closed, as the landfill has been developed on a brick kiln, sir. It was a brick kiln which has temporarily been abandoned, sir, and the place was completely empty. So the people and the municipal corporation thought of dumping the waste into that same place. Whether they could have taken the municipal waste to the municipal storage facility, which was around 15 to 20 kilometers, sir. And with a complete life cycle analysis being done, they could have completely seen the techno-economic feasibility of the study. But sir, rather than doing that, sir, they completely developed the landfill there, sir.
I know I'm taking more time, but like I just want to mention that we have technical solutions to solve the problems. It's there's other soft issues, so political issues. Yes. Those things needs to be resolved. So in terms of designing the closing the dump sites and designing the new landfills, making their sites usable, based on my presentation, you can see we don't have to make the landfills as a useless stuff. We can use them as a energy resources, and then at the end of their life, we can do a lot of things. We have multiple options to benefit that land, and and whatever resources that we can get in there. So my point is, a lot of things are done in India, in US. Maybe some of these things that can be looked into in research projects by MTech students or PhD students, and then maybe highlight those results, to the stakeholders. And somebody has to make the decisions, and these things cannot continue. If they keep on continuing, the problems are going to keep on worsening. And it becomes really challenging for everyone to address as we go further. The problems are going to become bigger and bigger, more complex. So it's better to solve them at early stages than later stages. So yeah, so just to summarize, the design of engineered landfills is well established, and the closure of remediation of the waste dumps is well established. And assessing the health impacts and environmental impacts of any waste disposal facilities is well established. So there are the solutions, and we really need to implement them. And a lot of this social, political, stuff that is beyond, the control of scientists and engineers. I have to play a role in making the real things happen. Thank you very much, everyone, for your attendance, and please keep in touch. And if you have any questions that I could not answer, please send me an email. I will be happy to answer those questions for you. Thanks again, everyone, and thanks for taking this wonderful course. And thanks again to Dr. Ramya and Dr. Rao for organizing this excellent course. And whoever is attending, you are getting something really worthwhile. You will appreciate this one in the future. Thanks again.
Thank you so much, sir. And I should appreciate for your energetic presentation even at late midnight to you. It's almost 12:45.
12:45 midnight, yeah, past midnight. So thank you very much.
Yeah. So we should appreciate a lot to you for your dedication. Yeah. So thanks again.
Yeah, thank you.
Ramya?
Yes, yeah.
Actually, we'll move to our next presentation. I think Professor Prashant, he's going to join in 1 or 2 minutes.
Yeah, I'm back. Yeah.
Oh, okay, sir. So first of all, please apologize, sir. So for delay.
It's a pleasure to listen to Professor Reddy.
Yeah. Yeah. So you can have a word with him, sir.
Yeah.
Yeah. Ramya, please.
Okay. So I'll share my
Okay,
presentation.
so welcome everyone. Yes. Sir, let me please introduce you to the participants. So it's a formality, maybe they know you well.